I wrote some prompts, and this came out. A video meeting app, think Zoom, but my own. Real video, screen share, host controls that actually enforce. Claude Code wrote basically all of it. One weekend, start to finish. So how do you actually build it? It really comes down to two tools. VideoSDK handles the real-time video, the genuinely hard part. And Claude Code writes the app as I describe what I want. Everything else is just Vite, React, and Tailwind. And one more tool. I add the Playwright plugin to Claude Code. It lets Claude open a real browser and test what it builds, and you'll see why in a second. Let's build it. First job, get real video working. I don't need it pretty, just two people in two browsers seeing and hearing each other, so I hand Claude a prompt describing exactly that. Full prompt's in the description if you want it. While it writes the code, I'll grab what it needs, my credentials. Over in the VideoSDK dashboard, I copy my API key and secret and into a .-env file. The important part, the secret never reaches the browser. It only signs a token at build time. VideoSDK uses two of these, one to join meetings, one to create rooms, both signed automatically at build. While it builds, here's the prompt in a nutshell: a minimal app with a create or join screen, a tile for everyone, basic mic, camera, and leave controls, all built against the official VideoSDK docs. Give it a few seconds to finish, and it doesn't just write the code. It drives the app with Playwright to check the call actually connects before handing it back. And we're done. A working call. I join in one tab, then again in a second, and they can see and hear each other. Mic off. Camera on, camera off. It's ugly, but it's real video running in the browser. Now the mental model, a few words and you'll understand any video app. A meeting is the room. It has an ID, that's the address everyone dials into to end up in the same call. A session is one live instance of that room. Open the same room tomorrow and that's a new session. Handy later for things like recordings. A participant is one person in the room. In code, they're just entries in a list. You're one, everyone else is a remote participant, and joining is just wrapping the app in a provider with your token and the meeting ID, then calling join. Exactly what you saw happen across those two tabs. Now let's make it pixel perfect. The catch is, the AI has to actually see the design, so I use Figma-CLI. It lets Claude Code read my Figma file straight from the desktop app. No MCP setup needed. If you want to follow along, the install link is in the description. Then one master prompt. The whole thing. Not just the look. The control bar, the panels, chat, reactions, the real-time wiring behind them, all of it matched to the Figma. This prompt is longer than the last one, so let me actually walk through it, because this is where the real work is, and it isn't the prompting. First, the design source. The design itself is a community Zoom UI file on Figma. I didn't draw it. And I point Claude at it through Figma-CLI, along with the structured design docs I built from it, every component, the spacing, the exact icons. So it's not guessing what Zoom looks like, it's reading the real thing, plus the extracted Zoom icons already in the repo. Next, the UI. Screen by screen, the top bar, the control bar, the speaker and gallery layouts, the pre-join screen, the side panels. And this VideoSDK doc, layout and grid management is exactly how the tiles arrange into those speaker and gallery views. Then, the behavior behind the UI, the part people skip. Chat and reactions ride on PubSub, that's this doc. Mic mute and unmute drives the control bar, that one. And the host controls mute all, waiting room, lock, remove, enforce for real, with the shared state synced over PubSub so late joiners stay in sync. And finally, the guardrails, reuse the Chapter 2 setup, match the Figma before adding anything, keep it type clean. Now, I'm speeding this way up because in reality, this was not one shot. I looped with Claude a lot, fixing spacing, swapping a generic icon for the real one, nudging a layout, then running it again. Pass after pass after pass. That back and forth is the actual work. It just doesn't make for exciting video. But eventually, it gets there. There it is. The control bar, the tiles, the panels, pixel for pixel against the design. So let's actually use it. Every panel, every control, every hotkey, all working. And remember that pub sub from earlier? Watch the chat. I type hi in one tab and it shows up instantly in the other. A hi comes straight back. Both directions, no refresh. Reactions work the same way. I send a clap from one tab and it pops up in the other. A heart from over here and there it is over there. That's PubSub doing its job. But here's the part that makes it a real meeting app, not just a video call, host controls that actually enforce, not buttons that look nice. Controls that really do something backed by that media server we talked about. Mute all, and every guest is muted at the server. Turn on the waiting room. And new people don't just walk in. They wait until I let them in. Perfect for a class or a client call you're not ready for yet. Lock the meeting, and anyone who tries to join after gets turned away. With a reason. And if someone needs to go, remove them, and they're gone. It came together the same way as everything else, by describing what I wanted. And there's plenty I'm not covering here. Polls, a whiteboard, screen share. It's all in the repo for you to try yourself. But let's get this thing online. Time to deploy. Last step, ship it. I push it to Versal. Set 2 environment variables, just the key and secret, and that's the entire configuration. No servers to manage. Now it's live on the internet. Let's test our deployed project. Create a meeting. And join from another browser tab. I'm in a real call. That's a video meeting app built and deployed in a weekend. And the whole project is linked below. Fork it and build your own Zoom.